All right, you guys ready to do some work?
Woohoo!
Work. Okay. Where does the unit for force come from?
Illinois?
Where's my
Illinois?
mouse? The net force is mass times acceleration. This we know.
That's Newton's second law right there.
We've seen it over and over again. It's our best friend by now.
That's right.
Units of force is newtons.
Yeah.
Mass kilograms. Acceleration is meters per second squared.
Boom.
This is where it comes from. Okay.
Just a reminder.
Yeah, a little heads up. What changes when a force is applied in something?
Could you give an example, Miss Moore?
Ball, softball, chillin'.
Sitting there. You're such a brute.
What is changing? Let's think about it. Work is done when an applied force causes something to move.
You were working just now, Ms. Moore.
I was putting in work. Putting in that work. When the force is in the same direction as the displacement, work equals force times distance.
It's how much force
displacement.
you're exerting and how far it goes
Yeah.
while you're exerting the force.
And one thing to keep in mind is force and displacement are both vector quantities.
Oh, that's right.
Vector times a vector is going to give us a scalar quantity. So work doesn't actually have direction.
Nope. Nope.
Oh, right, yeah. Okay. And here we go. Okay, work. Unit for work is a
Joule.
Force, newtons. Displacement, meters.
A joule is a Newton meter.
Joule is a Newton meter. And then joule, that's J. Newton times meter. And don't forget, Newton is this times an extra meter right there. So that's all of it. So a joule is equal to all of this right here.
Yep, so when you're working a problem, you got a bunch of units and you're putting them all together and you get something that looks like that bottom thing, it's a joule.
Don't forget. Pull the block at a constant speed for 0.5 meters.
Got your calculators, boys and girls? Let's do some calculating.
Let's do it. Okay. So we have a block with mass, and here is our meter stick, and we're going to right here, going until right here, 0.5 meter mark, and let's see. I'm gonna go on the other side. I guess, can you see that part okay?
Yep.
Okay, so watch for how much it's gonna be.
It's gonna be hard to keep it constant, but keep going, keep going, keep going, keep going. What do you want to call that?
5.5?
5.5. Okay, so the force was 5.5 newtons.
Oh my god, this is the worst pen in all of the history. Can you still see that?
Yes.
Okay, 5.5 newtons, and then
The displacement was 0.5 meters.
0.5 meters.
That's half.
Okay, I can do this, right? So what is the work gonna be?
2.5 plus 2.75, isn't it?
Oh my goodness, I'm gonna have to check my work, would you? Newton meters, that's a
Joule.
joule. Okay, so that's my work there.
That sounds valuable. Joules sound valuable.
A joule. Oh, now pull the block at a constant velocity with the scale held at a 45-degree angle to the track. I'm gonna grab my calculator too.
All right. We'll reset this.
Set it. Okay, and 45. Right about there, right? And you ready?
Go.
Ooh, it's like right there. It was like 6.3.
6.3.
Okay, so now work equals 6.3 newtons times 0.5 meters. 6.3 times 0.5, and I get 3.15 joules.
Huh.
Huh.
So you pull it the same distance, it's the same thing, but the angle was different.
It made me work more.
You had to do more work.
More work.
You
Oh.
needs to get paid for that.
Okay. What next? Work is how much force is exerted on an object times the displacement it moves in the direction of the force.
That last line's important. Is in the direction of the force.
Yeah, so the block was moving the same direction I was pulling it.
On the first one.
Yeah, on the first one, yeah.
The second one it wasn't, but we'll get to that.
Okay.
Oh.
Oh, go back.
Yep.
Softball?
Softball.
Okay,
Question time.
let's talk. Blinding. What direction is the ball going?
Up, Miss Mo.
Okay. What direction is the force on it?
Up, Miss Mo.
Okay, so direction's up, force is up.
Yep.
How about now?
Ooh,
What-
that's different.
What is the direction that the ball is going?
Down.
Okay, and how about the force now?
Well, you're gonna drop it unless it's up.
If it was down,
Oh my God.
right? So as I move the ball down, the direction is down, but the force is still up, right? I'm
There's
holding
something
it up,
different about that.
right?
I'm not quite sure what it is.
Yeah, so there's something different. Okay, how about where's the force now?
Still up.
Still up. What's the direction now?
Oh, it's horizontal.
It's not going up or down, right?
So that's got to be different too. Something's different about it.
We've
Not
got
quite
these.
sure what.
Yeah, we've got these 3 different scenarios.
So there's our definition. We need something Mo.
Okay. Well, let's go back to this then. Should I go to the next slide?
Go
before
to
I
the
talk
next
about
slide.
that? Work done by a constant force. We had before we were doing constant forces pulling that cart, right?
Yeah.
Work done by a constant force is this.
That's the complete definition of work right there.
Yeah, but so before our work equals force times distance, that was only partially true. It's only true when the direction and the force are in the same direction.
Good point.
But when I was bringing the ball down like this, the force is up, direction is down. We can't use that equation. We have to use this one.
Right. How do you know
So-
the angle?
That's a good question. Let's take a look what we got here.
All right.
Okay, so as I lift the ball up, okay, the force is up
Yeah.
and the direction's up.
Yeah.
What's that angle then?
Between up and up?
Yeah.
There is no angle. That's 0.
What's the cosine of 0?
Boys and girls, get your calculators out. Put the cosine of 0 in there. What do you get?
juggle, you know.
I got 1. It's 1.
It's 1. Okay, so 1, and it's positive 1.
Yes,
right?
it is.
Okay, so that means, what does that mean? Oh, that means that we multiply whatever it is by 1.
Yep.
Right? Now, what about the ball starts up here, force is up.
Yep.
Now the direction
The displacement is down.
is down. Down. What's the
the-
angle between up and down?
Up and down. That'd be 180 degrees.
Okay, so the cosine of 180 was that.
Pick up your calculator, boys and girls. What does it tell you? Dun, 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 dun. Okay, I get -1.
-1. So that means that force times -1 times whatever the displacement is gets you your answer.
And you'll be negative work. So when you're lifting it up, it's positive work, and when you're bringing it down, it's negative work. What was that other thing you did?
Force is
Up,
up. What direction am I going?
horizontal.
Horizontal.
What angle is that? Looks like 90 degrees to me.
Cosine of 90 is
Pick up your calculators, boys and girls. What's a cosine of 90? It's wait a minute. 0.
It's 0. Okay, so we don't do any work when we move horizontally.
Oh.
Okay. Moving right on. What does it say?
By definition.
By definition. Okay, and this says where theta is the angle between the force and the displacement. We just talked about that, right?
Got theta in the middle. It's between the force and the displacement. Sweet.
I think we're done here.
I think.
Work can be positive, negative, or 0, depending upon the relationship between the direction of the force and the displacement.
That thing.
That thing. Okay, I think they have everything they need, right, to be successful here. Page 165 in the AP Physics book. AP Physics, right?
AP Physics
AP
books,
Physics
yes
book.
ma'am.
And you're gonna do numbers 1 through 4 and lucky number 8.
It'll be fun.
Go. It'll be fun, they said.
All right, see ya.
See ya.